Hi, this is Joe. I wanted to show you real quick a calculator that I made might help you with homework 3. If you go down to the bottom of the page and click on excess notation, that worksheet, what I've made here is a quick calculator, and what you can do is this is only for 8-bit, but if you put in this 8-bit value, which is right here, and this value comes out of the example on page 74 at the top of the page. This is actually the 8-bit excess notation value for the number -9. And if you want to know how that number can be turned into -9, obviously, so the first bit is your anchor or base bit, and that represents 2 to the that bit stands for 2 to the 7th place, which is 128, but it's not turned on. So your turned on value, if it were turned on, it would be 128, but it's not turned on, so it's 0. If you go to the next bit, that is number n. It represents 2 to the 6th, which is 64. It is turned on, so your turned on value is 64. And you can go right down the line down your bits. So this is 2 to the 5th. That's the same as 32. And the value is turned on, so it's 32. Here's a value that's turned off. So it represents the number 8, but it's turned off, so its value is 0. If I go ahead and add up all those values that were turned on, it turns out to be 119. And I have to subtract then the base value that I was using. So that's dictated by the leftmost bit, which was 2 to the 28th. And I have to subtract 128 from 119. That's how I got to -9. So I have a little calculator that will tell me that. You guys are given a 32-bit number to interpret, so I started a calculator for you, and it goes clear over to the other side. So what you'll need to do to find out the value of that number, I did the first turned on value for you, which is that's 2 to the 31. Here's the number that represents. It's turned on, so my turned on value is this very large number here. This value obviously turned off. You won't need another calculation until you get down here, but that represents 2 to the 21st, which is this number here. It's turned on, so your turned on value will be this number right here. Once you're done with that, and hint, all you got to do is drop a certain formula or drag a certain formula, this one right here. You can sum up your turned on values. It would be right here. Your base value was 2147, blah, blah, blah. You just subtract that from your turned on values and you will have the answer. Now let's look also really quickly at the 32-bit floating point notation. Right here in row 5 is the original 32-bit binary number that you were asked to interpret. And you can just go from top to bottom and interpret this. So the mantissa sign is the left foremost digit if it's a 1. The sign is negative, otherwise it's 0, and this is all out of the book. So the sign is positive. This is noted at the bottom of page 78. So the mantissa sign for this one is negative since we have a 1. And you can click in there and see that I just used an if statement. I said if the value is 1, show me negative. If it's otherwise, show it positive. I just showed you over here in the excess notation calculator how to interpret this 8-bit number, which is stored in excess notation. So here's your original number. This bit stands for 2 to the 7th, which is 128. It's turned off, and so there's my all my turned on values. It's not worth anything, but I have to subtract that base value. So this value, all these zeros, is negative 128. The next part is the mantissa, and it's down here. We're going to start working next on the mantissa, and which is assumed to be a decimal number, which is represented by your binary added to the number 1. So let's consider our original value was the kind of pink line here, and so this first bit is n1, and that corresponds to 1 divided by 2 to the nth power, and if you work that out, it's a half. This one represents to a quarter, an eighth, a 16th, and you get the idea. And your original value will tell you, is that value turned on or off? So the value if on is indicated. Here's the first value that's turned on is 1/4. 1/8 is turned off, so is 1/16, but 1/32 is turned on. Here's the whole thing there. If you scroll down, you can sum up your bits of the turned on bits, and that's the sum of the turned on bits, but that number is assumed to be added to the number 1. So your true number is this 1.297. The mantissa then is equal to, there's a sign. The first bit tells us the mantissa sign. So there's lots of parts to just figure out this mantissa number. And finally, the value that we're looking for is the mantissa multiplied by 2 raised to the exponent. 2 to our exponent was negative 1/28. So our mantissa was this negative 1.29708. The exponent was 2.94 to the negative 39th. And if you multiply those, you get this very long number here. A couple of points on this. Obviously, we're not trying to get you to be computer scientists. This would be a whole math course to figure all this out. And each one of these ways of storing numbers is just an algorithm. The idea is that you get in and wrestle with one of these, and you're probably not going to sit down and work all this out in a calculator. This step is M, so that's 13 steps to get to this final answer. And so you're probably going to have to come up with a spreadsheet or a computer program in order to solve that. That's just part of the deal. Also, I know that several of you are frustrated that the book doesn't give a better explanation, and I understand that. I get it. Keep in mind, though, that you do have access to YouTube and the internet, and you might have to do a little bit more digging on this stuff, and it's going to be hard. You're going to wrestle with it. It's college, but I'm sure that you'll be fine, and I did just give you the answer, so hopefully your frustrations are allayed. Couple questions that you might want to consider on something like this. Why do you even use excess notation? Those types of things. What's the effect if you go out to 32-bit? But sorry, the other main point here would be you can see why a computer that is 32-bit versus 64-bit, obviously the 64-bit is going to hold a lot more information. So send me an email. I know this is pretty quick and dirty. If you're stuck or you have more questions, let me know. Have a good day.